Okay, hi guys. This is the first YouTube video that I'm doing over the homework. This one is over parallel lines cut by a transversal. So, welcome. Alright, so what we're doing here is we're determining whether or not these statements are true or false about the parallel lines cut through a transversal, about the angles, really. Alright, so I previously mentioned that these parallel lines that are cut by a transversal create two sets of four angles. So they create 8 angles. And those angles have special relationships. So what we're going to be doing here is looking at these angle relationships. So we start with number 1. Number 1 says that angle 1 and angle 2 are vertical angles. So let's take a look. Here's angle 1, and angle 2 is right next to it. So angle 1 and angle 2 do have a relationship, but they're not vertical. An example of vertical angle would be angle 1 and angle 3, right? They're right across from each other. Or like angle 2 and angle 4, right? They're across from each other. Angle 1 and angle 2 are actually a linear pair, right? If you look at them together, they form a straight line, which is called a linear pair. So that's false. These are a linear pair. Okay, so write the correct answer next to it if it's false. Alright, number 2, angle 1 and angle 5 are corresponding angles. Alright, so let's take a look at angle 1. Angle 1 is in the top right hand corner of the top intersection. And now look at angle 5. Angle 5 is in the top right hand corner of the bottom intersection. That means that they're corresponding. Corresponding angles are just angles that are in the same spot. So that's true. Another way I told you in class that you can, like a trick that you can use for corresponding angles, is look for one that's inside and one that's outside. So if they ask you about an angle relationship and you notice that one's outside and one's inside and they're on the same side, then they're probably corresponding. Okay? Number 3, angle 2 and angle 5 are alternate exterior angles. Okay, let's look at angle 2 up here and angle 5. For these to be alternate exterior angles, they would both have to be exterior. Now, angle 5 is inside the parallel lines, which means it's in the interior. Inside the parallel lines, these 4 angles are called interior angles. So the relationship between angle 2 and angle 5 can't be alternate exterior because angle 5 is not on the exterior. Angle 2 and angle 8 are alternate exterior. So are angle 1 and angle 7. Those are the alternate exterior angles here. Angle 2 and angle 5 do not have a relationship at all. So that's false. They have no relationship. Okay? Number 4. Angle 4 and angle 6 are alternate interior angles. So there's that word, interior. That means inside the parallel lines. Angle 4 and angle 6 are both inside the parallel lines, and they are on alternating sides of the transversal. So this is true. Angle 4 and angle 6 are alternate interior. Okay. Number 5. Angle 7 and angle 2 are corresponding. Alright, so remember on number 2, I said that corresponding is when they're on the same side of the transversal, and one is inside and one is outside. Angle 2 and angle 7 are both on the outside. Okay, so they're both on the same side of the transversal, but they're both on the outside, so they're not corresponding. Angle 2 is corresponding with angle 6, right? Angle 2 is in the top left-hand corner of the intersection at the top, and angle 6 is in the top left-hand corner of the intersection at the bottom, if you want to look at it that way. So that's false. And we'll put here, instead of writing that they have no relationship, we'll put angle 7 and angle 3 are corresponding. We'll fix it. Okay. Number 6. Angle 3 and angle 6 are interior angles on the same side of the transversal. Interior means inside. Angle 3 and angle 6 are definitely both interior. Now, are they on the same side of the transversal? The transversal is this line here, and angle 3 and angle 6 are both situated on the left side of the transversal. So this is true. They're interior angles on the same side of the transversal. All right. Number 7. Angle 3 is congruent to angle 8. Let's just take a look at angle 3 and angle 8 without looking at the relationship or anything. Let's just draw them. Let's draw a little arc. Notice that on angle 3 and angle 8, they don't look the same. Angle 8 is a very obtuse angle, and angle 3 is a very acute angle, meaning less than 90 degrees, and angle 8 is obtuse, which means greater than 90 degrees. So if they're congruent, that means they will have to be the same measurement. They would have to be exactly equal. Angle 3 and angle 8 are not equal, so they're not congruent. That is false. Okay, number 8. Angle 3 and angle 7 are corresponding angles. Let's look at angle 3. Is it inside? Yes. Angle 7, is it outside? Yes. Angle 3 is in the bottom left-hand corner of the intersection at the top. Angle 7 is at the bottom left-hand corner of the intersection at the bottom. They are in the same spot. So yes, those are corresponding. All right, number 9. Angle 8 and angle 2 are alternate exterior angles. Okay, angle 8 is down here. Angle 2 is up here. They are on alternating sides of the transversal. Angle 2 is up here on top, and angle 8 is on the bottom. And they are both exterior, so we call that alternate exterior. That's true. Okay, last one. If the measure of angle 8 is 112 degrees, find the missing angle measures. So let's label angle 8 112 degrees. Okay, now the cool thing about parallel lines that are cut by a transversal is that it creates two intersections that are exactly the same. So meaning all the angle measurements on each crossing are going to be exactly the same. So this one is 112 degrees, okay? That means that angle 4 is also 112 degrees. They're corresponding. They're the same. Then if you look at up here at angle 6 is vertical with angle 8. They're vertical angles, and vertical angles are the same. They're congruent. So that one has to be 112 degrees also, which means angle 2 has to be 112 degrees. Okay, then if we want to figure out the rest of them, I'm going to grab my calculator. Look at angle 5 and angle 6. You could also look at angle 7 and angle 8. Angle 5 and angle 6 form a linear pair, meaning they form a straight line. Straight lines are equal to 180 degrees. So I'm going to grab my calculator, and I'm going to subtract 112 from 180 because I need these two angles to add up to equal 180 since they form a straight line. And another word for that we learned is supplementary. Okay, so 180 minus 112 is 68. So that means that angle 5 is 68 degrees. That also means that angle 7 is 68 degrees because angle 5 and angle 7 are vertical. Now, since I said before that the top intersection is an exact copy of the bottom one and vice versa, that means that angle 3 and angle 1 are also both 68 degrees. See, we didn't even have to do any math for that. All we did was subtract one thing on the whole paper. So hopefully you guys got something out of this. I would also like for you to maybe look over your notes that we completed just so that you are getting more comfortable with vertical angles, corresponding angles, alternate exterior, alternate interior, and same side exterior and interior angles, because we are going to be continuing with those. And that is all. Have a great weekend.